In this video, we'll be going over reverse linked list 2. So given the head of a singly linked list and two integers left and right, where left is less than or equal to right, reverse the nodes of the list from positions left to position right and return the reverse list. So in our first example, we have the list 1, 2, 3, 4, 5, and then our left is 2, so we're currently at node 2 here, and right is equal to 4. It's going to be over here, and then we're going to reverse the nodes from left to right, so 2, 3, 4 turns to 4, 3, 2, and then we want to return the resulting list is 1, 4, 3, 2, 5. Let's go over the thought process. We will be keeping track of two lists. One list will be the resulting list, and then one list will be the reverse list. The resulting list will be 1 and 5, and then the reverse list will be 4, 3, and 2. We will need a way to keep track of the label of each node, which we will denote as I. If I is less than left or greater than right, we can append the current node to our result list. But if I is between left to right, we have to add the current node to the resulting list. Not the resulting list, the reverse list. Now, how can we determine when we can append the reverse list into our resulting list? Because eventually we need to have a reverse list inside our resulting list. If I plus 1 is greater than right, this means we're currently at the last node. If we're currently at the last node here, this means we know that we can append our reverse list into a resulting list. Let's go over the pseudocode. So we're going to create the following variables. The first one is the sentinel head. Is the sentinel head of the resulting list, and then we have stail is the sentinel tail of the resulting list, initially as head, and then our head is the head of the reverse list, initially null, and then we also have reverse tail, the tail of the reverse list, initially null, and then we'll also have our node, our current location inside the input list, initially the head of the input list, and then we have an I is our current label of each node. So while node is not equal to null, this means we still have nodes to process, but before we disconnect the current node, we want to save the next node. So we're going to create a variable next and set it to node.next. Then we'll set node.next to null. This disconnects the current node. Then we'll increment I, our current label. Because each node has a label, so currently we have a label of 1, 2, 3, 4, 5. Then we have if I is less than left or greater than right, we can append the current node to a resulting list. So I'm going to set stail.next to node, and we'll set stail to node. Else we want to prepend the current node to our reverse list. But before that, if stail is equal to null, we're going to set stail to the current node. This allows, for example, our first node here. So if we get to first node here, our reverse tail, if reverse tail is equal to null, our reverse tail is going to be null. So this is going to be the tail of our reverse list. For example, right here, this is the tail of the reverse list. So the first node that we want to reverse is going to be the tail of the reverse list. Now we want to prepend the current node to our reverse list. So I want to set node.next to reverse head, Then we'll set reverse head to node. It prepends the node. Now if I plus 1 is greater than right, we have reached the last node of our reverse list. This means we want to append the reverse list into our resulting list. So I'm going to set stail.next to reverse head, and then set stail to the reverse tail. This allows us to continue on from this node, so we can continue on to move forward. Now we can set node to next, allow us to move on to the next node. Then we can return the sentinel head.next, which is the head of the resulting list. Let's go over the time and space complexity. So time complexity is of n, where n is the number of nodes in the input list. We visit each node once, and our space complexity is of 1 because we just modified the input list. Let's go over the code. So we're going to create our sentinel head, sentinel tail first. Then we're going to create our reverse head and reverse tail, and also our current location inside the input list. And then we'll create a variable to keep track of our current label of the node. And then while node is not equal to null, we still have nodes to process. We want to save the next node before we disconnect the current node. Then we're going to increment our current label. If I is less than left, or I is greater than right, this means we can append the current node to our resulting list. So we're going to set stail.next to the current node, then we'll set stail to node. Else we want to first check if our sentinel the reverse tail is null or not. So if reverse tail is equal to null, we're going to set reverse tail to the current node. Then we want to prepend the current node to the reverse list. So we're going to set node.next to reverse head, and reverse head is equal to node. Now if I plus 1 is greater than right, we want to append our reverse list into our resulting list. So we'll set sentinel tail.next to reverse head, and then we'll continue moving forward from reverse tail. Then we're going to move on to the next node. Node is equal to next, and then we can return the sentinel head.next is the head of the resulting list. Let me know if you have any questions in the comment section below.